Hello folks, you're welcome to a fascinating geometrical video. The title of this video is titled A Classically Hard Geometry Problem. Some couples of months ago, a student of mine walked up to me demanding the solution of this particular problem. I must be honest with you. At the initial stage, when I took the problem from him, I was unable to solve the problem. I have to take it to my privacy and I carefully scrutinized the problem. That was when I got a solution for this particular problem. All right. So in this video, I want to present the solution to you in a logical and reasonable way. Now let's quickly delve into the solution of this particular problem. It reads, in the figure below, X is a point on BE. Now let's look at the figure that I'm talking about. This is the figure that is referred to. Now we are told that X is a point on BE. Now you can see line BE over here. This line is referred to line BE, all right? So I think I can erase this from here now. All right, so that is BE. Now X is a point on that line such that the angle EAX, all right, that is EAX is equal to EAD. Now you can see EAD here. EAD is 10 degrees. Can you see that? Look at the order of my pronouncements. EAD. Can you see that? So the angle there is 10 degrees. So we are told that the angle EAX is equal to 10 degrees also. Now from this information, we are required to show that line DX is parallel to line AB. Now if you observe the diagram, you will not find the point X. So that suggests that we have to draw a solution diagram and fit in the point X, all right? Usually, when you are given a geometrical problem, it is advisable to always draw a diagram. We call it diagram a solution diagram. This diagram enables you to put in some construction that will enable you to carry out the proof or solve the particular problem, all right? So it is best to draw out a diagram, and in such a diagram, we can construct any figures that will enable us to carry out the solution, the process of the solution, all right? So that is the first part. We have to show that the line DX is parallel to the line AB. Now the second part, we are required to find the value of X, all right, from what has been established. So let us look at the solution. So the first thing we do a redraw of this diagram. Now if you look over here, you see the redraw. Look at the redraw. This is exactly the figure you see above. Can you see that? All right. Now we are told that X is a point on line BE, and X has a property. What is the property? It exists in a way so that the angle EAX. So first of all, I will locate my point X. Let me say the point X is somewhere here. All right. I'll call this point X. All right. Then I will connect X to A, because we are told that angle EAX. So X has a connection with A. So in that case, I'll bring out my meter rule and show the connection. So what I will do here, I will connect this point X to point A. All right, that is the connection. So the next thing, this point of intersection, let's call it point G, for example. Let's call it point G. That's the point of intersection. All right. So we've made that connection. Now we are told that the angle. Let's go to the problem. Over to the problem. We are told that the angle EAX is equal to the angle EAD. All right, and the angle EAD from the original diagram is given as 10 degrees. So in that case, it follows that this place is also 10 degrees, because we are told that angle EAX. Look at the order. EAX is equals to angle. What is it given again? Let's look at it. angle EAD. All right, so that means that this point here is 10 degrees. Now from the original problem, you see that the entire angle is 70 degrees. So that means the remaining portion will be 60 degrees. So in other words, this portion here will be 60 degrees. All right. Hope you can see that. So we are required to prove that the first part of the question, we have to prove that line DX. Now we have to indicate line DX. So let's fit in line DX by our meter rule once again. So I'll bring in my meter rule now. We fit in line DX. All right. This is how we go about it. Yeah, this is line DX. So we have to show that this line DX is parallel to line AB. All right. So how do we show that? Now, there's something you should know about corresponding angles and alternate angles. First of all, let me illustrate over this location. If we have a line AB, for example, then we have another line CD, for example. Now, and I draw a line to cut across them. This cutting line is called a transversal. All right? It's called a transversal. Now, if you observe carefully, you see that angles are formed. Now, this angle you are seeing here is in the same position with this angle you are seeing here. So this angle that have the same position are called corresponding angles. All right. Also, the one you see here is having the same position with the one over here. So these two are corresponding angles. Likewise, this and this. All right, they are still corresponding. Then we can also name this also. All these are corresponding angle because they have the same position. All right. Then the one that have opposite position, such as this and this. Can you see that? They are having opposite position. Look at this one also. This and this. These two pairs of angles are called alternate angles. All right. So if I should label here as Y and I label here as Z, then Y and Z are alternate angles. If I should label here as P, for example, and I label it as M, P and M are what? Alternate angles. But take note, if I label it as T, T and Z are corresponding angles because they have the same position. So we can say corresponding angles are angles that have the same position, or you can say orientation. While alternate angles are angles that have opposite orientation. All right. So that is it. Now the fact that angles are corresponding or alternate does not mean they are equal. All right. So you should distinguish carefully between when angles are corresponding or alternate and when they are equal. These two things are different concepts. All right. Now, for corresponding angles to be equal, these two lines, AB and CD, must be in a particular orientation. The lines AB and CD must be such that they are parallel. Once this line AB is parallel to the line CD, all right, then we are sure that corresponding angles will be equal in size and alternate angles will be equal in size. All right. So take note of that. So if it's given that the line AB is parallel to the line CD, then corresponding angles will be equal and alternate angles will be equal. So in other words, for corresponding angles to be equal, the cutting lines such as AB and CD over here must be parallel. Otherwise, corresponding angles cannot be equal. Likewise, alternate angles. So take note of this. Conversely, if corresponding angles are equal, it implies that the cutting lines are parallel. So if we are told to prove that two lines are parallel, it's a matter of establishing the fact that corresponding angles are equal. If we can do that, then at the same time we have proven that two lines are parallel. You understand? So please, this I have said, you should be strongly borne in your mind because we shall use this idea in this particular problem. Now, we shall not be giving a detailed discussion on geometry because this is a past question. What we our aim is to solve it. All right. So you won't expect me to give you detailed explanation of concepts because that would take too much time and the video will be too lengthy. I want to avoid that so that you can easily go through the process and get the understanding of it. All right. So we shall assume familiarity with some concepts. However, If this is too difficult for you, I have two options before you. You can chat me up and make an arrangement with me whereby we will do one-to-one discussion. That is a private class. If you're interested, I can help you out in a private class. All right. I will be there to teach you, and you can reply immediately. It will not be a personal conversation as I do now, but it will be a one-to-one conversation. All right. I mean, it will be a two-person conversation. All right. In that case, you can communicate to me as I also communicate to you. All right. At the same time. But this one I'm doing now, I'm the only one talking. You don't have the right to talk to me. Of course, you know that this is a video. But in the personal class, I will be teaching you. You will be seeing what I'm doing, and you also will. I can see what you are doing. Then, if you are not clear, I can explain further. All right. That is one option. The other one is you click the link that is provided. It will take you to my Telegram group. Hereby, you can see a sequential order of topics that are clearly taught in a step-by-step process. All right. So these are the two options presented before you. Whichever is your choice, you take it. So, all right, let's proceed to the solution of this particular problem. So, we shall do some reasoning now. Let me wipe this out of this place. All right. So, we've done a redraw of the original diagram. This is the redraw, and we have constructed our points x. All right. So, we want to show that line dx is parallel to line AD. Now, to show that line DX is parallel to line AB, if we can show that corresponding angles are equal, we have done that. Now, look at this line. Let me bring something out for you so you can see clearly. Look at this. We have DA here, all right? Then we have, this one is not straight. Let me draw it again. Then we have DX. Let's say this is the case. Let's assume this, all right? Then we have a line coming from here, touching this, all right? Now, class, folks, rather, what is the name of these two angles? What do we call them? If you say alternate angles, you are definitely correct. Now, the fact that they are alternate angles, does it mean they are equal? No, it does not necessarily mean they are equal. All right. For them to be equal, the line dx must be parallel to the line AB. All right. Now, we call this angle xy. We call them alternate angles. Am I correct? Then if we can establish that s is equals to y, that these alternate angles are equal, then a consequence of this is that the line DS is parallel to the line AB. So we strive to show that these alternate angles are equal in size. If we can establish that they are equal in size, at the same time we have established that the line DX and the line AB are parallel. That's what we said initially. All right. So let's strive to establish this equality. Let's see whether we can establish something like this. All right. I bring out this from the figure to illustrate the points. So in this case now, we shall do some reasoning. Let me wipe this off. All right. Now, let's carry out our reasoning. Now, look at triangle BAG. Are you seeing triangle BAG? Look at it carefully. Please, you do me the favor of observing the order of my naming. When you look at the order in which I name triangle, you will know the triangle I'm talking about. All right. When I say BA, you've seen BA, then G. So that is a triangle BAG. All right. If you observe this triangle, the last angle is BG. Yes, you are right. BGA. All right, BGA. So we can say angle BGA is equals to, now you know the sum of angle in a triangle is 180 degrees. All right. So I can say 180 degrees. The other angles here are 60 degrees minus 60 degrees, and that will give me 60 degrees. Can you see that? That means the angles in triangle BGA are each 60 degrees. And what kind of triangle do we call that? Equilateral triangle. So we can say, therefore, triangle BGA rather, is an equilateral triangle. All right, we've established that. Now, observe, angle BGA, that is this angle, this symbol is for angle, it's not for triangle. Distinguish carefully between a triangle and an angle, all right? Angle BGA is equal to angle DGOX, all right? The reason being that, and that is 60 degrees also, the reason being that they are vertically opposite angle, all right? Opposite angles, that is the reason. So that means if here is 60 degrees, here is also 60 degrees, all right? Hope you can see that. So there's 60 degrees. So take note of that. Now we've established that already. Now observe carefully. Since triangle BGA is an equilateral triangle, it follows that length BA. Okay, let me put into writing so that it will be clear to you. So I can say since these are to present the proof in an examination. Since triangle BGA is equilateral, it follows, excuse me, all right, it follows that the length AB, which you are seeing over here, can you see that? It's AB. The length AB is equals to BG, and also equal to um, GA, all right? GA. So because in an equilateral triangle, the three sides are equal in length. So we have this, all right? So we've established that already. Now we want to consider two triangles. Now let's look at these two triangles, BGOX. Can you see BGOX? Hope it's clear to you. Let me remove this out. It will not be. So connect this to this and this to this. This point is G. All right. This G, and here is also 60 degrees. All right. Now let's consider two triangles. We're considering BGX and AGD. All right. Let's consider these two triangles and see what will happen with them. But before that, observe that in triangle BAD, the angles we have there are 60 degrees and 80 degrees. You may say, how? Where is the 80 coming from? Observe angle BAD. Angle BAD is made up of 60 degrees, 10 degrees, and 10 degrees again. So when you add up, you shall have 80 degrees, all right? So in effect, triangle BAD has two known angles, which are 60 degrees and 80 degrees. So 60 degrees plus 80 degrees will give me what? 140 degrees. That means this other portion will be 40 degrees from angle sum in a triangle. So I can call here 40 degrees, all right? All right. Then let's also consider another triangle. Let's consider triangle BAOX. Are you seeing BAOX? BAOX has two known angles, which are also 60 degrees and 80 degrees. You may say, where is the 80 coming from? The sum of 60 and 20 will give me 80. All right. So in effect, triangle BAOX has two angles, one 60 degrees and the other 80. So that means the last angle here should be 40 degrees also by angle sum in a triangle. Hope you can see that. All right. Then let's consider triangle BAE. Can you see triangle BAE? Now locate it with your eye before we proceed. BAE. All right. I believe you have located it. Now, triangle BAE has two known angles also. One is 80 degrees and the other is 70 degrees. You may say, where is the 70 degrees coming from? Now look at it. In triangle BAE, the first angle is 80. That 80 is the sum of 60 and 20. Can you see that? That is 80, all right? While the other angle is the sum of 60 and 10, making 70. So in other words, there are two known angles here in this triangle, one 80 degrees and the other 70 degrees. That means the last angle, which is over here, should be 30 degrees by the sum of angles in a triangle, all right? So we've established these things already. Now, what we want to do, we want to consider the triangle BGOX. Don't forget that this point is G. If I let me put the G here so that it not be confusing. This point is G, all right? Now I want to consider two triangles BGOX, that is BGOX. Can you see that? And AGD. Let's consider these two triangles. So I will come here and write. Before that, look at this. This statement we made just now. This statement that is here. It means that we can say BG is equal to GA. All right. And let's label this as 1 for simplicity's sake. All right. Let's call it 1. Then we can write consider triangle. What triangles are we considering again? Triangles what? BGOX and AGD. Triangles BGOX and AGD. All right. So that is what we are considering. So we want to consider these two triangles and prove that they are congruent. Now, congruency is another concept that I need to explain to you, but time will fail me to do that, as we are based on solving problem, not a detailed explanation. But we assume the knowledge. Let's assume that you are familiar with the concept of congruency, all right? But I will try my possible best to bring it home to your understanding. Now, we are considering triangles BGOX and AGD. If you look at triangle BGOX, now the side BG is equal to the side AG, all right? We can make that statement. We can say side BG is equal to side what? AG. Why are we saying so? Because of equation 1. In equation 1, we have already established it. Look at it over here. Can you see that? BG is equals to AG. That is the equal size of an equilateral triangle, right? So we've done that. Let's look at another thing that is common again. Now, also angle GBX is 20 degree. Can you see that? Angle GBX is 20 degree, and that is equal to angle GAD. Angle GAD is also 20 degree because 10 plus 10 will give me 20, all right? So I can say angle GBX equals to angle GAD. So I can say angle GBX is equal to angle GAD, all right? And that is 20 degrees. Can you see that? Then with the next thing we want to seek for is the other angle. Look at this other angle. Angle GOXB in a triangle BGOX. Angle GOXB is 40 degrees, and that is equal to angle GDA. All right. So angle GOXB is equal to angle GDA. So we come here and write angle GOXB is equal to angle GDA. All right. And that is equal to 40 degrees. Now, these three equalities is enough to show that the triangles are congruent. That is, they are equal in all respects. Congruent triangles are triangles that are equal in every respect. All right. So we can now make the statement of congruency as follows. We can then say, therefore, triangle BGOX is congruent. This is symbol for congruent. Congruent to triangle AGD. All right. Now, what condition of congruency do we use to establish this? We use the fact that the two corresponding sides are equal and two angles are also equal. Look at them over here. Can you see that? So in that case, we shall put SAA. This is the condition of congruency we used. That is a corresponding side and two given angles. So by this, we have established that the two triangles are congruent. That is, are equal in every respect. In respect of size, they are equal. In respect of angle, they are equal. In respect of area, in every respect, all right, they are the same. That is the meaning of congruency. All right, so we have established that already. So because of that established, then we can say, let's go to the diagram again and make good choice. Then we can say, we can say that GX, okay, now over here is GX. Can you see that? This is GX. So this order, the order must be maintained so you get the right naming. Length GS will be the same thing as length GD, all right? So I can say, therefore, length GX is equals to length GD. Hope you can see that. All right. Then we've established that already. Now, from 1, look at 1. In 1, we established that GB is equals to GA. Let's locate it in the diagram. Look at GB, and then we have GA over here. All right. Can you see that in the diagram? Now, we shall do something to 1. Now, the following is very vital. We say add length GX to both sides of 1. All right. Let's do that. Now, in equation 1, we have that GB is equals to GA. So I can write GB and I'll add words to it now, GX, all right? And it's equals to GA, all right? And I'll also add GX to it, all right? So let's locate GB plus GX in the diagram. Let's locate this in the diagram, GB plus GX. Let's go to the diagram. So we have GB over here, then we have GX over here. Now to make things good, since GX is equals to GD, that is in this line you are seeing here, we can write this left-hand expression as GB plus, instead of GS, I can put GD there because they are equal, right? Equal to, then this one will remain invariant, GX. Hope you can see what I'm doing. Now, this latter expression, let's look for it in the diagram, that is GB plus GD. Now, without the diagram, we can even make clever statements. Now, GB plus GD, we give rise to GD. All right, can you see that? GB plus GD. Sorry for this. This naming is, let's look at the naming properly. Hope we don't make any mistake. Okay, we are right. Okay, so we are very correct. But I'm coming, excuse. Let's look at something carefully. This GB, this GD, GB plus GD. Okay, this is BG. We are making a mistake here. This is BG, not GD. You see that now? So what we are having here is supposed to be, this point supposed to be BG, all right? From 1, look at 1 carefully. Have you seen it? Is BG equals to GA? Hope you are seeing that. That was where we made the mistake. So we have this written down already. So I think we are in good order. All right, GA done. So we're in good shape. So that means I will also remove this from here and put BG. Can you see that? Okay. So BG plus GD is equals to BD. All right, become BD. So I will remove this and put BD. So if you are adapting it, you can go to the diagram and locate it. Don't you see that BG plus GD is, we give it entire length BD? So we are very correct, all right? Now we'll go to the right hand side of the expression. Where is the right hand side? GA plus GX. Let's locate it in the diagram. GA, yes, GA. This GA. GA plus GX. We give it the entire length AX, all right? So I can come here and write AX here. So we've established that this side BD is equal to this side AX. Now let's go for further establishment. Let's look at the diagram once again. Let's carefully look at the diagram. Now observe carefully from the diagram. Now let's consider triangle B, let's look at triangle BDX and triangle AXD. All right, let's look at these two triangles, triangle BDX and AXD. Let's write it down. Now consider triangles BDX and AXD. All right. So we're looking at these two triangles now, BDX and AXD. All right. Now in triangle BDX, we discover that angle DBOX is 20, and that is equal to angle XAD. because that is 20 also because it's 10 plus 10, all right? So we can come here and write BDOX angle BDOX is equals to what triangle would we spot just now? XAD, all right? Write XAD there. XAD, and that is 20 degrees. We've seen that. Now also we'll go over to the diagram again. You discover also that, now observe carefully. Let's look at okay, even without this angle, hello, without this angle, hope you can get what I'm saying. Without this angle, we can still solve the problem. Let me remove this from here. This will be a long process. Without the angle, we can see cleverly solve the problem. Look at it. Now you discover that bx, side bx is equals to AD. Why? Don't forget we have established that triangle BGOX is congruent to triangle AGD. All right. So if BGOX is congruent to AGD, it means that the side BX, which is what you are seeing here, this BX should be equals to AD. All right. So I can let me call this star, for example. Let me call this star. Then I can say from star, the length BX is equal to the length, what do we have there? AD, all right? I can say equals to AD. Can you see that? Also, from the triangle, you will discover something. Now look at this DX, line DX. Line DX is common to both triangles. That is, line DX is common to triangle BDX and triangle AOXD. So DX is a common length. So I can come here and write line DX is equal to line DX. All right. So from these three conditions, 1, 2, 3, I can say that triangle BDX is congruent to triangle AOXD. Therefore, triangle BDX is also congruent to triangle AXD. All right. And what is the reason for congruency? Is side, side, side. That is the reason behind the congruency. All right. So we've already established that these two triangles are congruent. And if they are congruent, it follows that, let's come over to the diagram. It follows that the angle over here, this entire angle is the same as this entire angle. All right. Now, you know, a portion of it is already 40 degrees in each case. So that means if this portion is alpha, this portion will also be alpha. All right. So in effect, it shows that the triangle GDOX is an isosceles triangle because it has two of its base angles to be equal in size. So because of that, the triangle GDOX is an isosceles triangle. So we can say from triangle GDOX, we have that alpha plus 60 is equals to 180 degrees. That is the angle sum in a triangle. That means we have that 2 alpha is equals to 1, that will be 120 degrees, all right? Then alpha becomes 60 degrees. So that means each of the alphas is 60 degrees. So here is 60, here is 60, all right? So have we not shown that this angle here, this angle DOX A, can you see that? Look at it, DOX A. Please locate it, DOX A. This DOX A is the same thing with alpha, all right? So we've shown that angle DOX A is 60 degrees. So if I should draw my diagram again over here, this is A, and I put B here. Then this is D. I put ox. That I connect A to ox, all right? Now this is my alpha, right? This is my alpha, but we have established that it is 60 degrees here. And this angle here, it has been 60 degrees from the beginning. So that means alternate angles are equal in this case. And if alternate angles are equal, what follows? It shows that the cutting lines must be parallel. That was what we explained earlier on. Hope you remember that. So it follows that the line DX is parallel to the line AB. All right. So I can come here and make this statement, and this is equals to, okay. All right. Let me say, I will now say therefore angle, I can now say angle DOX A. All right. DOX A is actually equal to angle OX AB. All right. So I can come here and write angle OX AB. So I've established that means that line DOX is indeed parallel to line AB. So this is the first portion. So in the I part of the problem has been solved. This is the proof. And this is the I part of the problem. We are done with it. So we'll go to the I part of the problem. Where is the I part? It says hence find the value of x. So we have to find the value of x. All right. Now there's a consequence. Let's look at the diagram carefully. Since this line DX is parallel to the line AB, it follows that this angle here is 80 degrees, because the angle here is known as angle CDOX, and that is equal to angle DAB. All right. Angle DAB and angle CDOX, they are corresponding angles. And you know angle DAB is 80 degrees because it's a sum of 60 degrees and 10 degrees and 10 degrees. Now 60 plus 10 plus 10 will give me 80. That means if this whole portion is 80 degrees, here also will be 80 degrees. All right. Let's come over here. That is angle DOC. Now angle DOC is equal to angle ABOX. Please note the reason why we're making this equality is because we have established that the line DOX is parallel to the line AB. Because of that, we can make this equality. We are very correct. So this angle here is also 80 degrees because the angle over here is 80 degrees. Can you see that? So that means this one is 80 degrees. And that implies that the triangle DCOX is an isosceles triangle. All right? So that means this portion will be 20 degrees. It will be 20. Let me mark it out. It'll be 20 degrees. All right. So we've done that already. Now we want to find the value of S. The question is, how do we find the value of S? Now what we shall do, we shall go with by a very logical process. We will connect the point C to the point G. All right. So I'll bring out my meter rule again. This is my meter rule. Sorry for that. Let's connect the point C to the point G. All right. So I have something of this nature. Can you see the connection? So we've connected the point to this point C, and the connection is such that the angle here is 10 degrees, and the angle here is 10 degrees. In other words, our line CG is a bisector. All right, it's a bisector. Now, you may argue that why do you feel that this line will bisect? We deliberately draw it like that. We draw it to bisect the angle 20 degrees so that each part will be 10 degrees. All right. So in that case, we have some important shapes here. I mean triangles. Now look at triangle CAG. Can you see triangle CAG? Now consider triangle CAG and also consider there's one other triangle we'll consider, triangle CAG and triangle CAE. All right, let's consider these two triangles. CAG. Have you seen that? Don't forget this point is G. Hope you can see that. This point is G. All right. So we're considering triangle CAG and triangle CAE. All right. So let's write it down. So we're over to the I part of the problem. Now consider triangle CAG and triangle CAE. All right. Let's look at these two triangles and see what happened to them. And if you observe triangle CAG and triangle C, because this is CAG and we have CAG. From 10, I'm coming, excuse me, from 10 to 20. Then we have, okay, from 10. So let's call it AEC instead of CAE, all right? Let's call it AEC. So I will remove this from here. AEC. The reason being that when naming congruent triangle, you have to be careful in naming so you can tell corresponding side and corresponding angles accurately. Otherwise, you'll make a mistake. All right. So the correct order of naming is CAG and AEC. All right. So let's go back to the diagram again. We have CAG. That is, we move from the angle 10 to the angle 20. Then, in order to follow the same thing in the other triangle, it will be AEC. Moving from the angle 10 to the angle 20 again. AEC. Hope you can see that. So that is the order in which they should be named. And if you look at this carefully, you see that the side AC is common, and the angles in each triangle are the same. That means the triangles are again congruent. So we can say triangle CAG is congruent to triangle AEC. All right. So I can come here and make the statement. I can say triangle CAG is congruent to triangle AEC. What is the reason? Side, angle, angle. You can look at the diagram, just compare them. You see that they are like that. We are true in saying so. All right. CAG is congruent to triangle CAE. Have you seen that? All right. So having done this, we can now make some statements that are very vital. We can say side CE. Here's side CE. This is CE. All right. This side CE is equal to side AG. So therefore, we can say length AG is equal to length what? AC. So let's go to the diagram to locate them. Have you seen that? This is CE, all right? Why this is AG over here? So we have AG, all right? This is AG and this is CE. Now look at triangle AOC. Can you locate triangle AOC? Are you seeing it? Triangle AOC. In triangle AOC, you discover that the two base angles are equal. And if the base angles are equal, it implies that the triangle AOC is an isosceles triangle. All right. And if it is an isosceles triangle, it means that the length AOX is equals to COX. So I can come down and write over here. Also, since triangle AOC is isosceles, the length AOX is equals to the length COX. All right. So if I make that statement, I'm not wrong. Let's go back to the diagram again. AOX, COX. Now, the length AOX can be broken into AG plus GX. So I can come here and write AG plus GX AG plus GX in the place of AOX, all right? Equals to now CX, the same thing with CX. CX will be CE plus EOX, all right? Let's look at it. Can you see that? CE plus EOX. So that's what you are seeing over here. Now, don't forget, we've already established that AG is equals to EOX over here. Look at it here. Can you see that? That means that in the place of AG, I can replace it with EC. Then plus GOX equals to CE plus EOX. All right? From whence this we cancel out with this. Then I'm left with GOX equal EOX. All right? So let's go back to the diagram and locate this. That is, we want to locate GOX and EOX. So in the diagram, we have G ox to be over here, then this is E ox, all right? This is E ox. So that means that, now please observe carefully. Don't forget, the angle over here, we have it at 60 degrees, while our alphas are each 60 degrees. You know, we've established that alpha is 60 degrees. So what can you say of triangle GDOX? Is it an isosceles triangle or an equilateral triangle? If you say equilateral triangle, you are correct because the angles are each 60 degrees. So therefore, the triangle GDX is an equilateral triangle. All right. Now we've established that EOX is equals to GOX. So I will come down and write GDX is an equilateral triangle. So in that case, I can come here and say, now triangle GDOX is an equilateral triangle, right? So in that case, length GD is equals to length DX, and that equals to length GX. All right, I can make this statement. Now in this line, we've already shown that length GX is equals to EX. All right, so I can come here and let's look at the diagram once again. I can now say that let EX is equals to DX. All right, so let's use that equation. So therefore, all right, have I replaced this? So I will replace GX with EX. All right, then I can say therefore length EX is equals to DX. All right, let's go over to the diagram and look at it. So EX equals to DX. Yeah, that is it. Now listen to me. If length EX is equals to DX, what can you say of triangle DXE? I give you 1 minute. What can you say of triangle DXE? If you say an isosceles triangle, you are absolutely correct, because in an isosceles triangle, the two sides are equal. And since we have established that line EX is equals to line DX, it follows that triangle DXE is an isosceles triangle. And if that is the case, we have that this angle over here. So if I call here this angle over here, this is angle EDX. It's the same thing as angle DEOX. All right, that is angle EDOX is equal to angle DEOX. Take note of that. Now don't forget, listen, this point here, this angle over here is 40 degrees. All right, and we have established that alpha is 60 degrees. So that means the entire angle is 100. And if it is 100, this remaining portion will be 80 degrees because of the sum of angles on a straight line. All right, there will be 80 degrees. So we now have that this entire angle here, which is 30 plus x, is equals to this angle over here. Because why? Triangle DXE or DEX is an isosceles triangle. So let's take the sum of the angles in the triangle. If we take the sum, we shall have 30 plus x, which is the first angle, plus 30 plus x again, because the triangle is an isosceles triangle, plus 80 equals to 180 degrees. Can you see that? Let's go over to the diagram again so you locate it one more time. Look at it. Now we have established that EOX is equal to DX. All right, that makes this triangle DOXE an isosceles triangle. And in that connection, the angle over here 30 plus x should be equals to angle XDE, or you can say EDX. So if we're making this statement, we're absolutely correct. So let's solve for this problem. This will imply that we have 2 of angle 30 plus s equals to 100. All right, when you take 80 this way, you have 100 as the result. Then divide through by 2. We have, this implies we have 30 plus x equals to 50. All right, so when we solve for x, it means that s is equal to 20 degrees. So this is the answer. So you see that this problem is quite complicated. So I advise you to go over it once, twice, and thrice to get a full grasp of it. And should in case you are confused, you can reach to me, indicate, and I will try my best to explain clearly to you. All right. So take your time and go through this video. And don't forget that this platform offer a private tutoring service. So if you are in need of a private teacher, a personal teacher, you can connect with me, and I will help you out with in that your request. All right. So let's call it a close for the now. Thank you very much for listening. I really appreciate your presence.